We've encountered a new trigonometric function, so our first task is to compute its derivative using the definition of the derivative. So the derivative, recall that that's defined as the limit as h goes to 0 of sine of x plus h minus sine of x divided by h. Now let's simplify this down. We're going to use the sum of angle formula for the sine function. Recall, sine of the sum of two angles is the same as sine A cosine B plus sine B cosine A. So we can expand this and write this in the form of sine x cosine h plus sine h cosine x minus sine x. And all that is divided by h. Now, let's group together some terms. First of all, let's take all the terms that have sine x as a factor. There's one such term here, and that is multiplied by cosine h. And there's another one here, so that gives us a minus 1. And all that is divided by h. The term that's left over is cosine of x, and that's multiplied by sine of h over h, and then we have to take the limit as h goes to 0. Now on the side here, I've put two very useful limits. We're going to use both of these. So the first of these tells us that the limit of sine of h over h, as h gets smaller and smaller, is 1. And therefore, this factor right here is going to approach the value 1. At the same time, we have another limit that tells us that this expression tends to 0 as h goes to 0. And that tells us that this whole thing will go to 0, and in fact, this whole factor will disappear. So all in all, when we evaluate that limit, we get simply cosine of x. And so we've been able to show that the derivative of sine x is simply the trigonometric function cosine x. And a similar calculation, which you can try for yourself, is to compute the derivative of cosine x. And when we do so, it turns out with very much the same kind of manipulation and steps, except we use the sum of cosine formula and we get minus sine of x.